All right. Let's continue to look at 7.5. We can go through the rest of these problems, examples of them. We need to get everything on one side before we try to determine if it's positive or negative and do the factoring. So subtract the 3u, subtract the 3, and now we are less than but not equal to 0. So we are asking, where is the function negative? So we have 4 terms. It's time to factor by grouping. Factor out a 4u, leaving us with u plus 1. Factor out a negative 3, leaving us with u plus 1. So our factors are 4u minus 3 and u plus 1. Where is this function less than 0? So we find these solutions. Where would we hit the x-axis? And we find the solutions by setting this equal to 0. Like so. So for number 2, you just have to distribute, move everything to the left, factor by grouping, find your solutions. And now we make our number line. We have -1 and 3/4. If you want to think about this as a decimal, on the number line, that's okay. Students will ask, what does it mean by exact solutions? On the first video I made, we had like 2/3 and -2/3. We could not use 0.6, of course. That would be an approximation. So this is what it means by exact. 0.75 is what we call a terminating decimal. So it wouldn't matter if we used 0.75, but get used to using the fractions, I guess. So what are the test regions? We can test 0, anything to the left of -1, like -10, anything to the right of 0.75, so we could use 1, we could use 5, whatever. If we're using the test method, it's easiest to plug this into the factored form. So if we test -10, that's 4 times -10 minus 3 times -10 plus 1, because that's the factored form. It's easiest to plug these into the factored form. So 4 times -10 is -40. -40 minus 3 is a negative value. It's -43. -10 plus 1 is -9, which again is a negative value. So a negative times a negative is positive. So when we plug -10 into the function, we get a positive value. But again, think about how the quadratics work. We're making a parabola here that hits the x-axis at these two solutions. We could plug in +10. We would get 40 minus 3 is positive. 40 plus 1 is positive. we could take the time to plug it in, but that's going to be the positive region. Again, this is how the quadratics work. If it's a 4u squared in this case, we have our variable to the second power. Once we have this on the number line, we can kind of see where is it negative. It's negative right here, from -1 to 0.75. Again, it's easy to test 0. So let's verify this. 4 times 0 minus 3. That zeroes out, and we're left with -3. 0 plus 1 is just 1. -3 times 1 is -3. That's the negative region. Once you get, really, once you get the polynomial on the left side, maybe you went straight to the calculator. And maybe you could kind of hunt for these solutions. I talked about that using trace. 3/4 is kind of a normal fraction. So where are we negative? The only value in which we are negative is -1, 2, 3/4. And again, we use parentheses because there was no line under the symbol. I'll do number 4 real quick using the calculator. A version of number 4 would be something like m squared is less than 49. You could use the square root method, excuse me. But I like to think about this as factors because we're in the zeros unit. Move this down. So we know what this is going to be, m plus 7, m minus 7. So we have x squared minus 49. If I graph this, again, -7, +7. If it's if the symbol is less than 0, it's where is the function negative. And on the calculator, that's just below the x-axis. So from -7 to +7. No line under the symbol here, so we would use parentheses. If you had a line under the symbol, you would use brackets. So for number 5, we have a cubic function. These are not always as easy to see on the calculator. But let's get everything on one side. And you can see that this will factor nicely by grouping. Don't miss that it's an a squared that we're factoring out, leaving us with 3a plus 5. Here, if there's no factor, we can only factor out a 1. In this case, bring the sign down, a -1. So we're dividing both of these by -1. We're less than 0. So that's our shared factor that we have once. And then a squared minus 1. Maybe you'll get a different difference of squares. But this one, students will miss a squared minus 1 as a difference of squares, but it is. The square root of 1 is 1. So this is where we get our factors, our solutions, would be to set these equal to 0. Move the camera down again. So we get a equals, divide the 3, negative 5/3. This one's easy, negative 1 and positive 1. So these are the solutions. Remember, if we have 3 solutions, then we will have 4 regions to consider. So we have 1, and then we open towards infinity. If you want to, you can think about this as like negative 1.6 repeating as you put it on the number line. Don't make a mistake. As you put these pieces on the number line. Negative 5/3 is less than negative 1, so it's to the left of negative 1. So we could look at the image in the calculator. Again, it just takes a lot of time to test these values, but you certainly could. Don't forget that we go towards negative infinity. Something to the left of negative 5/3, you could test, negative 2 or negative 10, whatever. It gets a little bit tricky here. That's where we'll kind of spend our time talking. Negative 1 to 1, that's testing 0. That's easy. Oh, I'll show you to use the table. That'll be good. That'll be helpful. Anything to the right of 1, let's test, 5 or something. So I said think about this as negative 1.6, and I wrote that down for a reason, which I forgot about. But it's because this is maybe a little bit tricky to think about. What's between negative 1 and negative 1.6? Well, we could test negative 1.1, negative 1.2, negative 1.3. You get the point. These are really the only values that we could test between negative 1 and negative 1.6. So let's talk about using the table. I'll go with this part where we are on the left side, because we have to be on the left side if we want to put this into y equals. So 3x cubed plus 5x squared minus 3x minus 5. And I will hit graph. I'm going to move the camera down. There we go. It looks almost like we're bouncing right here. But there's something happening there, so let's take a look. Again, we're asked where is the function negative. There are 4 regions to consider because we found 3 solutions. We can see that we start below the x-axis. So from negative infinity to our first solution, we are negative. So negative in this region. But again, I wanted to show you the table. So let's think about that. Go to the table and let's test. Anything like negative 2 gives us a negative value. Anything to the left of negative 2, like negative 3, negative 4, negative 5, these are negative values. We can use the table to test when x is 0. We see a negative 5, so we're negative at 0. And then I said let's test positive 5. Or really anything to the right of 1. You can see that these are positive values. So we're positive over here. The question will be, what are we between -1 and -5/3? The table is not going to help us with values such as -5/3. But this is why I constantly tell you about the trace button. If I hit trace, I can type -5 divided by 3, and it tells us that y is a 0. So, again, I like that trace feature. We verified that that's a 0. We couldn't really verify that in the table. But let's test. So trace -1.1. We can see that we have a, let's see, autofocus. Oh, that's the light. Sorry. Hey, that maybe helped. At -1.1, we have a positive value. It's a 0.352, but it is positive. Let's trace at -1.2. Again, it's a very small number, but it is positive. I can type -1.3. Once I'm in trace, I don't need to hit trace every time. At -1.3, it's a very small number, but it's positive. And it will be the same at -1.4 and -1.5. It would be kind of cumbersome to plug in a value like -1.2, so I like to just use the trace feature. So we are positive in that region. Let me move this up. So again, all we care about is where the graph is positive or negative. We are negative from, let's see, no line under the symbol, so parentheses all the way around. The graph is negative, or the function is negative. The graph goes below the x-axis from -infinity to -5/3. Here you would have to use -5/3 in Alex. And then we were also negative from -1 to +1. And that's what we would put into Alex, because it wants the interval notation of where the polynomial is less than 0. So I hope that helps. Let me know if you have any questions.